A finite state machine AM is defined as a finite memory machine of order mu if the last mu number of input symbols and the corresponding output symbols could be used to determine the current state exactly. That means with the knowledge of the last mu input symbols and the corresponding output symbols, will be able to determine the present state Si exactly. In that case, we say that it's a finite memory machine of order mu. Now, in order to determine whether a given finite state machine is a finite memory machine or not, and to find out the order, there are two techniques. Number one, it could be done by using a testing table and then drawing a testing graph, and number two, by using a vanishing matrix method. Now in this tutorial I'm going to show you how to do it using a testing table and testing graph. Let us consider an example. This is a finite state machine. This is the given finite state machine. Now we need to determine whether this is a finite memory machine, and if it is so, then we need to find out the order. Now first of all, what you need to do is to develop a testing table for this. So list first of all the given states A, B, C and D. Then the input output combinations. That means for 0 input 0 output, what you get. Then for 0 input 1 output. Then for 1 input and 1 output. Then for 1 input and 0 output. And then 1 input and 1 output. So remember this thing, that this is the input and this is the output. This is input and this is output. So first of all, let us check the given machine. Now what we get, the present state A is transited to B on given input 0 and provides output 0. So for 0 input 0 output, A goes to B. So for 0 input 0 output, A goes to B. Now what happens for 0 input 1 output? Is there anything? If we give 0 input and we are getting 1 output by transiting to some state, is that happening for this machine? No, it's not there. So you should leave it blank. Now for 1 input and 0 output, is something happening here? For state A, if we give 1 as input and we are getting 0 output, it is not happening here. So what we are getting here is nothing. For 1 input 1 output, when we are giving input 1 and we are getting output 1, the state A is transited to C, so it should come to C here. It should be C here. Now for B, what we are getting, for 0 input 0 output, we have D here. For 0 input 1 output, for 0 input 1 output, we have nothing. For 1 input 0 output, for 1 input, this is 1, I'm sorry, this is 1, this is 1. For 1 input 0 output, we are getting this. So for 1 input 0, for 1 input 0 output, for B, for 1 input 0 output, we are having C here. Then for 1 input 1 output, we have nothing. So for C, what we are getting here, 0 input 0 output, it's D. 0 input 1 output, we don't have anything. 1 input 1 output, it's C, it's 1 input 1, it's B, and 1 input 0 output is nothing here. So for D, what we have, 0 input 0 output, it's C, 0 input and 0 output is C. Then 0 input 1 output, we don't have anything. Then 1 input 0 output, yes, we have A. Then 1 input 1 output, we have nothing. So this is the upper part of the testing table that we built. This is the upper part of the testing table. Now we need to build the lower part of the testing table by combining the states in this way. Now this is the lower part of the testing table. Now combine A with B, and that is your first set here. So what happens here? Now we are having this uncertain state A and B for the testing table, uncertain pair of states A and B, and we need to find out the implied pair for A and B. And what you are going to do is to just union this. For AB, the implied pair is going to be B union D for 0 0. Since nothing is there, so nothing should come here. C and nothing, it should be nothing. C and nothing, it should be nothing. So for AB, the uncertainty pair AB, the implied pair is BD. Now you need to do it again for the other combinations. So there will be 6 combinations overall. AC, it's BD again for the first, because A and C, if you combine them, then B and D comes here for 0 0, nothing comes here, nothing comes here, and nothing comes here as well. Then A and D, do it in this way: first AB, then AC, then AD, then BC, then BD, then CD. So AD is BC, then you don't have anything here, you do not have anything here, you do not have anything here. For AD it is BC. Now what you are having here, for AC we have one more, I'm sorry, for AC what we have here, BD, and then we have here BC. So BC should come here, and then AD we have done with AD, now it's BC. For BC you have DD here, if same pair appears, same pair comes, right, the DD, something like that. Same thing here, that one will be dealing with this. Now C, nothing, nothing. Now BC is done, so BD is CD, then AC, then nothing, then CD, that last one. CD is CD, then nothing is here, nothing is here, and nothing is here. So this is the lower part of the testing table, and this is the upper part of the testing table. So we have done building the testing table. Now what we need to do is to develop a testing graph in order to test whether this finite state machine is a finite memory machine or not. And in order to build the testing graph, this is the upper part, remember, this is the upper part, and this is the lower part, or upper half, lower half, whatever you say. Now in order to build the testing graph, what you need, each vertex of the testing graph is actually the combined state pairs. So AB, AC, AD, all these are, there are 6 vertices in the testing graph. So AB is one vertex, AC is another one, AD is another one, AB, AC, AD, BC is going to be the other one, BD, and the last one is CD. So these are the 6 nodes. There are 6 nodes in the testing graph. Now what you need to do, there will be a directed arc from the uncertainty pair to the implied pair. That means AB is the uncertainty pair and this is the implied pair, BD. So there is going to be a directed arc from AB to BD in the testing graph. So AB to BD is going to be an arc. So AB to BD, we are making an arc from AB to BD, because AB is the uncertainty pair and BD is the implied pair. Now again, from this testing graph, testing table, AC arrow BD should be there. So AC arrow BD is an arc, and AC arrow BC will be another arc. AC arrow BC will be another arc. Then AD arrow BC is going to be another arc. AD arrow BC is going to be another arc. BC arrow DD. Now if same state appears twice, you should leave this. BD arrow CD, just leave this. BD arrow CD, BD arrow CD should be there, BD arrow CD should be there. So this is BD arrow CD. Now BD arrow AC should also be there, BD arrow AC should also be there. Now CD arrow CD, you should write in this way, CD arrow CD. Okay. So again, you can write the input output sequence for that as well. That means AB arrow BD is an arc, AB arrow BD is an arc, and this is for 0 input 0 output. So you can mention it here. You can mention 0 input 0 output here in this way. Now again, AC arrow BD is there, so you can mention 0 input 0 output for this. Okay, now in this way you can build the testing graph. Now if the testing graph contains any loop, then the given machine, given finite state machine, is not a finite memory machine. Now here we see that it contains a loop, AC BD and BD AC, so it's not a finite memory machine. If the testing graph is free of loop, then it is finite memory machine. So what we did, On given the finite state machine, you build the testing graph, upper half of the testing graph, then you build the lower half of the testing graph. Then first of all build the upper half of the testing table, then build the lower part of the testing table by using the information in the upper part. Then using the lower part of the testing table, build the testing graph. If the testing graph contains any loop, it's not a finite memory machine. Let us consider another example. Now it is the given finite state machine. Now we need to check whether this finite state machine is a finite memory machine or not. So what we are going to do, it is the present state. Now we should check the combinations of input and output. So 0 input, 0 output, 0 input, 1 output, 1 input, 0 output, 1 input, 1 output. So for A, B, C, D. Now for A, what is happening here? For 0 input, 0 output, we have the state D here. For A, 0 input, 1 output, we do not have anything. For A, 1 input, 0 output, we do not have anything. For 1 input, 1 output, we have this A. 1 input, 1 output, we have this A. For B, it's 0 input, 1 output, 0 input, 0 input, 0 output, nothing is there. 0 input, 1 output, it's D. 1 input, 1 output, it's A, and nothing is there. For C, what we are getting? 0 input, 1 output, 0 input, 1 output is B, and 1 input, 1 output is also B, and we do not have anything here. So for D, what we have here, 0 input, 1 output, it's A. For 0 input, 0 output, nothing is there. For 1 input, 1 output, it's C, and nothing is here. For C, it is 1 input, it's B. Okay, so this is what we got as the upper part of the testing table. Now we need to build the lower part of the testing table by using the information of the upper part. So there are these combinations: AB, AC, AD, BC, BD, and CD. Okay, so for AB, what we have here is D nothing, so it's nothing. D nothing, it's nothing. D nothing, nothing, it's nothing. AA should come here. For AC, it's D nothing, nothing. AC, it's B nothing, so nothing comes here, it's AB. For AD, it is nothing, nothing. If one is nothing, then the result is nothing, so it is AC. For AD, it implies AC. For BC, it is nothing here. For BC, it is BD here. For BC, it is nothing here, it is AB here. For BD, it is nothing here, it is AD here, it is nothing here, again AC is here. For CD, it is nothing here, it is AB here, it is nothing here, and it is BC here. So this is the lower part of the testing table that we have built. Now using the information of this lower part, each of these state combination will be a node in the testing graph. So there are going to be 6 nodes. AB is 1, AC is the other, AD is the third, BC is the fourth, BD is the fifth, and CD is the last one. Now what you need to do is to draw the arcs. Since AB arrow AA is there, they are the same pair, so we are leaving this, we are not counting that. AC arrow AB is there. Since AC is the implied, AC is the uncertainty pair and AB is the implied pair, so AB should be there because AB is the implied pair and AC is the uncertainty pair. So AC arrow AB should be one arc. Let me use some different color. Okay, so it is AC arrow AB. Then AD arrow AC should be there, AD arrow AC should be there. Then BC arrow BD and BC arrow AB should be there, BC arrow BD and BC arrow AB should be there, BC arrow AB should be there. then BD arrow AD, BD arrow AD, then BD arrow AC, BD arrow AC, then CD arrow AB and CD arrow BC, CD arrow AB and CD arrow BC. So this completes the testing graph. Now what you need to do is to find out the longest path. Or first of all, you need to check whether this testing graph contains any loop or not. As you can see that this testing graph doesn't contain any loop, so obviously this is a finite memory machine. If the testing graph doesn't contain any loop, it is a finite memory machine. So it is a finite memory machine. Now we need to find out the order mu of this finite memory machine. For that, what you need to find out is the longest path of this testing graph, and we can see that it's BD arrow, AD arrow, AC arrow, AB. It is 1, 2, 3, and it could be more as well. Let me check. It's CD arrow, BC arrow, AB is 1, 2, BC arrow, BD arrow, AD arrow, AC. So BC arrow, BD, this is going to generate the longest path. I have got this. This is BC arrow, BD, then BC, BD arrow, AD, then AD arrow, AC, then AC arrow, AB. This is the longest path. So I'm marking this 1, 2, 3, 4. So the length of the longest path L is equal to 4. So mu is equals to length of the longest path, that is L plus 1, that is 5. So this is a finite memory machine, obviously, because the testing graph doesn't contain any loop, and the longest path of this machine L is equal to 4, and the mu is L plus 1, that is 5. That's the order of the finite memory machine mu. It is 5 for this given machine. That's all for this session. Now in this tutorial I actually demonstrated how to find out whether a given machine is given finite state machine is a finite memory machine of order mu or not, by using testing table and testing graph. In the next tutorial I am going to show you how to check it out using the vanishing matrix method. Thank you.